right? Okay, the first question was digits in base 8 number systems. Okay, first of all, let me summarize the things that we did. We have learned about the number systems. So previous day, we have learned about the number systems. And there are 4 number systems in your syllabus. The first one is binary number system. The second one is octal. Third one is decimal. And the fourth one is hexadecimal number system. Okay, let me first explain, then I'll ask the questions, then you have to answer. I'm going to summarize the things that we have discussed previously. Since there are new students, I'm going to tell it from the beginning. Okay, the first number system is binary. First number system is binary. In binary number system, this is also called base 2 numbers. So you can write down if you don't know. Right? Binary number system, base 2 numbers. The digits used in base 2 numbers. Digits used in base 2 numbers are 0 and 1. The digits used in base 2 numbers are 0 and 1. And what is the base of base 2 numbers? It's 2. Right? And if I give an example, this is base 2 number. This is example for base 2 number. Base you are going to write in here. Using this small digit, you are going to write base 2. Okay, so can you tell me the positional values? So you have to talk now, right? Please talk. Can you tell me the positional values? So what is the positional value of this bit? Yes. What is the positional value of this bit? Hello, can anyone respond? Nipuni? Joel? What is the positional value of this number? Yes? Hello, can you talk please? Shall we turn on the videos? If you can't talk, shall we turn on the videos? අපි videos on කරමුද ඔයාලා කතා කරන්නේ නැත්තම්? Right? So because I don't know, you have to talk, right? So the positional value of this bit is, yes, it is 1. The positional value is 1. How you rename this is 2 to the power 0. මේකට අපි කියන්නේ 2 බිංදුවෙනි බලය. ස්ථානීයගේ positional value is 2 to the power 0. 2 to the power 0 is equal to 1. Then you have here you can, so let me put this into the table, into a table. I have the note and presentation, but I'm not going to use that. හේතුවක් තියෙනවා presentation එක පෙන්නුවම ඔයාලා කලින්ම උත්තරේ කියනවනේ ඒක දැක්ක හැටි. ඒ හින්දා අපි මේක හදාගෙන යමු. හදුවට පස්සේ මම presentation එකයි note එකයි පෙන්නන්න. මොකද so why I have to repeat today? Page number. So no page number, just we are discussing about number systems. This is your third lesson basically. Number system is your third lesson, and no need to look at the book. So forget about the book. I'm thinking I'm doing this without the book, but so you can refer to the book later. First, without looking at the book, tell me the values. So if I'm going to add this into a table, so let me add this into a table. This is the first digit 1 1 0 0 1.11. And what is the positional value of this? You said correctly, 2 to the power 0. Okay, what is the positional value of this bit? What is the positional value of this bit? Second one. Yes. Positional value of this bit?
0.
That is the bit value. I'm asking about positional value. ඔයාලට මතකද අර පොඩි කාලේ ගණක රාමුව කියලා එකක් එහෙම තිබ්බා. ඒකේ තිබ්බා 1 ගොඩවල් 10 ගොඩවල් ඊට පස්සේ 100 ගොඩවල් 10 ගොඩවල් ඒ විදිහට තිබ්බා නේද? In abacus you have then base 10 ගමුකෝ 10 පාදේ සංඛ්‍යා. Think about decimals, base 10. In abacus, you have ones, then tens, then hundreds, then thousands. Okay, here you read this number. Let's say this is an ordinary number. How you read this number? 4 thousands. And then you have 5 hundreds. 4 thousands. Then 5 hundreds. Then 6 tens. And then 0 ones. This is how you are reading. No? Then 4,000 plus 500 plus 6 tens plus 0 ones is 4,560. If you have 2 here, then 2 ones. So this is for base 10 decimal numbers. Okay, I'm asking about base 2 numbers. So what is the positional value of this? Okay, if it is difficult, right? Okay, if it is difficult, let's discuss decimal. Okay, let's discuss decimal and then come to this, right? Decimal number system. So decimal number system you call base 10 numbers. These are the numbers we are using day-to-day life. Base 10 numbers. These are the numbers we are using day-to-day life. Okay, remember that after today's lesson, I'm not going to repeat this again. Today I'm explaining from the beginning. So if you come to today's class, no matter whether you pay or not, I don't mind, right? That is up to the institute and all. But even if you can pay or cannot pay, forget about payment, you have to come to the class. Otherwise, it is very, very, very difficult to teach. Because මේ සතියේනවා තව සතියක් ඔයාලා නිවාඩු ගන්නවා එහෙම આવොත් නම් මට උගන්වන්න අමාරුයි. එහෙනම් හොඳම දේ තමයි දරුවනේ ඔයාලා එන්න පන්තියට. ඊට පස්සේ අපි payment එක ගැන බලමු. If you have any difficulty to do payments or whatever the things, please let me know. I'll talk with them and help you arrange that. Okay. And also another thing, humble request. කාරුණික ඉල්ලීමක් තියෙනවා කතා කරන්න. ඔයාලා කතා කරේ නැත්නම් තරහ වෙලා වගේ හිටියොත් සමහරට දැන් උදේ අර නැගිටලා රතිඤ්ඤ දාලා මේ එහෙම නිින්ද ගිහිල්ලාද දන්නේ නැහැ. පාන්දර නැගිටලා විශ් කරන්න එහෙම බලාගෙන ඉඳලා දැන් සමහරට නිින්ද ආගෙන එන වෙලාව වෙන්නත් පුළුවන්. නැත්නම් කාටුන් එකක් යනවා දන්නේ නැහැ ටීවී එකේ ඒක බලන ගමන්ද දන්නේ නැහැ නෙන්නේ. එහෙම වෙන්නත් පුළුවන්. මම දන්නේ අඩු ගානේ මට මූණු ටික බලන්න තිබ්බනම් මොකද වෙන්නේ කියලා හිතා ගන්න පුළුවන්. අපි අඩුම ගානේ ඊළඟ දවසේ පොඩ්ඩක් ලස්සනට ඇඳලෙමු මේ එතකොට කැමරා එක ඔන් කරලා බලන්න පුළුවන්. කැමරා එක ඔන් කරලා බලාගෙන මූණ බලාගෙන කතා කරමු. I think that's easy. I can turn on my camera but only if you can turn on your cameras. එහෙම නැත්නම් මමත් compromise කරන්න හොඳ නැහැ නේ. Right, okay. Base 10 decimal number systems. Right, base 10 number system. What is the base? Yes, kindly talk using microphone. No one is going to no one is going to grab your voice and keep it in a safe. So I know your voice is really valuable. So I think I want to pay you to, then only you will talk. It's like that much valuable, right? Anyway, so what is the base of base 10 number system or decimal number system? Yes. Hello.
10. 10.
Yes, base 10 number system, base is 10. What are the digits used in base 10 number system? What are the digits used in base 10 number system? Yes.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
8, 9, correct. And this is example. Okay, this is example of base 10 number system. You write base with subscripted way. This is how you write the base, but it is optional to write base in base 10 number system because that is the number system we use in day-to-day life. So then you should know the positional values. Okay, let me take a table like this. In this table, let me write this 4, 5, 6, 2, 4, 4 5 6 2.56. Okay, can you tell me the positional value of this? අර ගණක රාමුව මතක් කරලා කියන්න මෙතන තියෙන කීයේ ගොඩවල්ද? Yes.
2 to the power 1.
2. This is base 10.
10 to the power 0.
10 to the power 0. Yes. 10 බිඳුවෙනි බලය ගොඩවල්. 10 to the power 0. ඒ කියන්නේ එකේ ගොඩවල්. ඔය විදිහට මේ ටිකත් කියන්න පුළුවන්. Can you tell this one, and this one? Here 10 to the power. Yes.
1.
10 to the power 1 means tens. Here 10 to the power
2.
2. 10 to the power 2 means 10 into 10. What is the value? 10 into 10 means
100.
100. Here 10 to the power 3. 10 into 10 into 10. What is the value?
1000.
1000. Correct. Here what is the value? 10 to the power. After decimals, you have minus values, right? 10 to the power minus 1. You write this as 1 divided by 10. Here you have 10 to the power minus 2. You write as 1 divided by, yes, 1 divided by, yes, you have to tell. Come on. 1 divided by 100. So 10 to the power minus 1 means 1 divided by 10. 10 to the power minus 2 means 1 divided by 100. If it is 10 to the power minus 3, what will happen? 10 to the power minus 3. Then what is the value? Yes, 1 divided by
1000.
1000. Right? If it is 10 to the power 4, what is value? 10 to the power 4. What is value? It is, yes,
10,000.
10,000. Okay. Then what you have to do? How you find the value of this? How you find the value? You have to multiply this one by this 2. 1 by 2. What is the value? 1 into 2 equal to this one. 6 into, sorry, 10 into 6. What is the value?
60.
Here 100 into 5. Value is 500. Here 1000 into 4. Value is 4000. Okay. So here 1 divided by 10 into 5. What is the value? 1 divided by 10 into 5. What is the value? Yes, yes, yes. This is basic mathematics. 10න් එකේව පහක් කීයද? 10න් පහයි 10න් පහයි කියන්නේ 0.5 නේ 0.5. 100න් එකේව 6ක් කියන්නේ කීයද? 100න් 6යි කියන්නේ 0.06. 0.06. Okay, shall we write down this? So since I think even though kamanna parana hitapu kattiyat kamanna, please write. I'm repeating the lesson, right? I'm doing this again because some are new student and some have not understood this. Some have not done the exercise. Okay, can you write down this decimal number? So write down the heading number systems. Main heading is number systems. And under number systems, please write down this one, decimals. Number systems, please write down this one, decimal numbers. Okay, quickly write down and let me know after finish, right after writing. Okay, finish writing. ඉවරයිද ලියලා පුතේ?
Yes, sir.
තාම ලියනවද? ඉවරයිද නැත්නම් තාම ලියනවද?
ඉවරයි.
ඉවරයි නේද? අනිත් පැත්ත ඉවරයිද? Finish writing. Okay. So if you can at least 2 or 3 Bhagya writing. So please quickly write and finish, right? I'll give you 1 more minute. But you have to write this part. Huh? No, don't write the other parts. Write this part only. Only the highlighted part. හරිද? ලියලා ඉවරයිද? දැන් ඇතිනේ. Right. If you finish writing this, now okay, now think about the binary number. දැන් ඔය decimal දිහා බලාගෙන binary දිහා බලමු. එතකොට ඔක පැහැදිලි. දැන් ඔයාලා binary ගැන ප්‍රශ්නයක් වෙන්නේ නැහැ. Okay. Now can you look at the decimal number and tell me about the binary number? So what is the positional number? So you can see base is 2. In binary, base is 2. Digits are 0 and 1. Because base is 2, digits are 0 and 1. 0 වලින් ඇවිල්ලා 1 වලින් ඉවර වෙනවා. මේක 0 වලින් පටන් ගෙන 9 වලින් ඉවර වෙනවා. Right? මේක 0 වලින් පටන් ගෙන 1 වලින් ඉවර වෙනවා. Okay, tell me the positional values now. Here 2 to the power 0. What is the positional value of this one? 2 to the power?
2 to the power 1.
Yes, correct. 2 to the power 1. Good. Then next one. 2 to the power.
2,
3.
Next one, 2 to the power 3. Next one, 2 to the power 4. This one, 2 to the power point ne dashamana, 2 to the power minus 1. So this one, 2 to the power minus 2. Now can you tell me the value of this? What is 2 to the power 0? දෙකේ බිඳුවෙනි බලය කියන්නේ කීයද value එක?
1.
It's 1.
1.
This one?
2.
This one?
4.
4. This one?
6,
8. Right? So how you calculate? Always double. Here make a 10 times නෙවෙයි මේක 10 ගුණයක් වුණානේ. 1 10 ගුණයක් වුණාම 10යි, 10 10 ගුණයක් වුණාම 100යි, 100 10 ගුණයක් වුණාම 10යි, 10 10 ගුණයක් වුණාම 10 10යි. 1 became 10, 10 became 100 because 10 times 10, this is 10 times 10 times 10, 1000, 10 times 10 times 10 times 10. So similar to that here, 1 time 2, then 2 times 2, here 2 times 2 times 2 means 8. Here 2 into 2 into 2 into 2. What is the value? 2 into 2 into 16. Then මේ විදිහට නෙවෙයිද අර RAM එහෙම එන්නේ 1 GB, 2 GB, 4 GB, 8 GB, 16 GB pen drives 1 GB, 2 GB, 4 GB, 8 GB, 16 GB. Now that is how it happens. Okay, so then what is the value of this? 2 to the power minus 1 equal to 1 divided by 2. That is equal to 0.5, no? දෙකෙන් එකයි කියන්නේ 0.5. Here 1 divided by 2 to the power minus 2 means 1 divided by, yes, one divided by 2 to the power 2 කියන්නේ කීයද? This is equal to 1 divided by 2 to the power 2 is equal to 1 divided by 2 to the power 2 is what? Here 1 divided by
4.
4. 1 divided by 4. 1 divided by 4 is equal to 0.25. 4 එකයි කියන 0.25. හරිද? දැන් මේ පැත්තටත් ඔක පුළුවන්. ඔයාලා මේ පැත්තට හිතන්නකෝ. 16 තියෙනවා. 16න් භාගේ 8යි. 8න් භාගේ 8 divided by 2 4. 4න් භාගේ 2යි. 2න් භාගේ 1යි. 1න් භාගේ 0.5යි. 0.5න් භාගේ 0.25. හරි නේද? මේ පැත්තට හිතන්න පුළුවන් නේද එහෙම? හිරුසර වට දැන් ඇහෙන්නෙත් නැද්ද? හිරුසර you are telling about a problem. දැන් ඇහෙන්නෙත් නැද්ද හිරුසර වට? අනිත් අයට ඇහෙනව නේද?
Yes, sir.
Okay, others here. මම හිතනවා හිරුසර දැන් වාට ඇහෙනවා ඇති කියලා බලමු. මම මේකට උදව් කරන්නම් මේකෙන් පස්සේ ක්ලාස් එකෙන් පස්සේ. ඔයා මට WhatsApp message එකක් දාන්න පුතේ ඔය ප්‍රශ්නෙම කියලා. ඊට පස්සේ මම ඔයාගේ කම්පියුටර් එක බලන්නම් මොකද්ද වෙලා තියෙන්නේ කියලා. හරි ඉස්සලා මට ඔය WhatsApp message එකක් දාන්නකෝ ක්ලාස් එක ඉවර වුණාට පස්සේ මම අද ඉවර කරන්නේ 9. දැන් මේක නෙමෙයි මට 11 පන්තියක් තියෙනවනේ 11 ඉවර වෙන්නේ 10ට. ඒ හින්දා 10න් පස්සේ හරි හෙට උදේම හරි message එකක් දාන්න. Okay, now can you tell me whether you understood this concept, the positional value concept? Did you understand or not? So starting from 2 to the power 0, starting from 2 to the power 0 to 2 to the power 1, 2, 3, 4. The power is increasing. When you go to left side, power is increasing. When you go to right side, power is decreasing. දකුණු අත පැත්තට power එක වැඩි වෙනවා. වම් අත පැත්තට power එක වැඩි වෙනවා. දකුණු අත පැත්තට power එක අඩු වෙනවා. ඒ වගේම දෙකේ පාදයේ සංඛ්‍යාවක් නම් දෙකෙන් තමයි වැඩි වෙන්නේ. 10 පාදයේ සංඛ්‍යා 10න් වැඩි වෙවි ඉස්සරහට ගියා. දෙකේ පාදයේ සංඛ්‍යා දෙකෙන් වැඩි වෙවි ඉස්සරහට යනවා මේ පැත්තට යනවා. දෙකෙන් බෙදි බෙදි පිටිපස්සට එනවා. 10න් වැඩි වෙවි ඉස්සරහට යනවා. 10න් බෙදිලා පිටිපස්සට එනවා. So that is the method. Understood or not? Clear or not? Clear or not? It seems not. You are not responding means not clear. Okay, so let's increase. Yes. Okay, tell me what is the value of 2 to the power. So I'm asking. So if there's additional bit like this, another one. Now, what is the value of that bit? What is the value of that bit? This another one. What is the value of this bit? 2 to the power?
5.
Yes?
2 to the power 5.
Correct. Okay. So what is the position of what is the value of 2 to the power 5?
32.
32. Okay. Are others understood or not?
Understood, sir.
Okay. So only few are responding, right? Others, if you cannot understand, please let me know. Then I can help you. Rashmi, what තේරුණාද පුතේ?
Yes, sir.
Okay. ඊට පස්සේ let's say Nipuni. Did you understand Nipuni? Srima පල්ලෙ මුල්ල කිලි නම්මගේ නම් ඉඳින්නේ. Okay. Vanshika පුතේ තේරුණාද නැද්ද? කතා කරන්නේ නැහැ නේ. හරි. Ravindu?
Yes, sir.
Okay. Right. Then if you all understand, then we can move. Right. Okay. So if you cannot understand, kindly let me know, then I can repeat and explain. Hari. මම ඔයාලගෙන් ප්‍රශ්න අහනවා කියලා නම් හිතන්න එපා. ප්‍රශ්න අහන්න ඔයගොල්ලෝ කැමති නැත්නම් මම අහන්න නැතුව ඉන්නම්. හැබැයි ඒක නෙවෙයි ප්‍රශ්නේ. ඔයගොල්ලෝ උත්තර දෙන්නේ නැතිකොට ඔයගොල්ලන්ටමයි පාඩුවක් වෙන්නේ දරුවනේ. ඒ හින්දා හැම වෙලේම ඔයගොල්ලෝ උත්තර දෙන්න එක බය වෙන්න එපා. මම දන්නවා ඔයගොල්ලන්ගේ ජෙනරේෂන් එක වෙනස්. ඔයගොල්ලෝ පොඩක් ඩෑෂ්බෝඩ් ජෙනරේෂන් එකක්. ඒ වුණාට අපි චුට්ටක් ක්ලාස් එකේදී උත්තර දීලා බලමු. ඒක වෙන ඒකෙන් ඔයාලට පාඩුවක් වෙන්නේ නැහැ. කතා කරා කියලා පාඩුවක් වෙන්නේ නැහැ. හරි. එහෙනම් උත්තර දෙන්න. තේරුම් නැත්නම් අන්තිම ලැජ්ජ වෙන්න එපා. තේරුම් නැත්නම් තේරුම් නැහැ කියන්නේ. මොකද අනිත් ඔක්කොටම තේරිලා. ඔයාට තේරුම් නැත්නම් ඔයා මේ තේරුණා කිය හිටියොත් එහෙම ඔයාට පාඩු. පන්ති අපි හිතමු ළමයි 15ක් ඉන්නවා. 15න් 14කට තේරිලා ඔයාට තේරිලා නැහැ. දැන් ඔයා අනිත් 14ම කියන තේරුණා කියලා. ඉතින් ඔයත් බලන 14 දෙනාම කියනවා මම කිව්වොත් මට මාර ලැජ්ජාව වෙන්නේ. දැන් තේරුනේ නැහැ කියන්නත් බෑ. අනිත් 14න් තේරෙලා මටත් තේරුණා. හරි හරි. එහෙම කියන්න එපා. එහෙනම් අනිවාර්යෙන් තේරුම් නැත්තම් නෑ කියලා කියන්න. ඒක මට කරදරයක් නෙවෙයි. එහෙම හිතන්නත් එපා. මට ප්‍රශ්නයක් නෑ. අනිත් එක මෙහෙමයි මම දැන් ඔයගොල්ලන්ගේ පන්ති සමහර දරුවන්ට So at least tell me even after the class. Class එකෙන් පස්සේ හරි වාට එවන්න පුළුවන් මේ සර් මේක පොඩ්ඩක් ආයෙ කියලා දෙන්න පුළුවන්ද කියලා WhatsApp message එක. හරි? WhatsApp message එකක් එවන්න පුළුවන්. සර් මේක තේරුන්නේ නැහැ මට කියලා දෙන්න කියලා. ඉතින් එහෙම මේ කියනවා නම් ඊට පස්සේ මට පුළුවන් ඕගොල්ලන්ට වෙනම session එකක් දාලා තනියෙන් හරි එක කියලා දෙන්න. හැබැයි ඔයාලා කියන්න ඕන පුතේ හරි නැත්තම් වැඩක් නැහැ නැත්තම් අපි තේරුම් ඒ කියන්නේ තේරුම ගන්න නැතුව ඉස්සරහට ගියොත් තේරුමක් නෑ. හරි මම ඊළඟට හරි මේකටත් උදාහරණයක් දෙන්නම්කෝ මම. එතකොට කොහොමද දැන් මේ ගාන හදාගන්නේ? මේවා වැඩි කරන්න ඕන. හරි මට වැඩි කරලත් උත්තර කියන්න. 1 into 1 it's 1. Then here what is the value? 2 into 0? 2 into 0? 0. 4 into 0?
0.
0. 8 into 1?
8.
8. 16 into 1?
16.
16. 32 into 1?
32.
32. It's very easy, right? 0.5 into 1? 0.5. Ekamani. 0.25 into 1? 0.25. Hari neda? 0.25 into 1? 0.25. Yes, very good. All have now you are little bit okay. Then one buy an chuttak. Hari kata karla inno hondai. එහෙම තමයි ඉන්න ඕන. හරියට පස්සේ මොකද්ද කරන්න ඕන? මේ ටික එකතු කරන්න ඕන. You have to add these numbers 32 plus 16 plus 8 plus 0 plus 0 plus 1 plus 0.5 plus 0.25. So now what is the value? Can you add and tell me the value? Quickly add all these numbers. 32 plus 16 plus 8 plus 1 plus 0.5 plus 25. Yes? What is the value? It is? Yes, you can add.
$114.75.
Yes. 32 plus 8 is 40, no? 32යි 8යි 40යි 16යි 40 16යි 56යි 56යි 1යි 57යි. Then this is 57 point දශම පහකුයි දශම දෙකයි පහකුයි කීයද? 750කුයි 725කුයි 775යි නේද? 57.75 in decimal, and this is how you convert it to decimal. Understood or not? තේරුණාද නැද්ද? Hello. Okay. Others?
තේරුණා සර්.
තේරුණා සර්.
මගේ උත්තරේ හරිද? අඩු ගන්න එහෙමත් කියන්න හරි නම් හරි කියලා. නෑ වැරදිද? හරි නේද? 32යි 8යි කීයද? 32යි 8යි 40යි 16යි 56යි 1යි 57යි දශම පහකුයි 7යි. දශම 7යි පහ. Okay. So this is how we calculate. So shall we write down this? Binary base 2 numbers, shall we write down? This is how you write base 2 numbers, and this is how you convert the base 2 numbers to base 10. Okay, quickly write down this. If you have finished, write down, let me know, then I can go to the next one. In blue color, I have highlighted the number. The number digit will be multiplied by the positional value and then add all values to get the decimal number. Similar to what you did in decimals. These are the number digits. Let me highlight in same blue color. Number digits you multiply by the positional value and add them up. Then it will give the decimal value. In binary also you do the same thing.
Yes.
Yes. Finish writing now, everyone. Have mommy or I need?
Yes sir.
Okay, good.
Yes, sir.
Right. So see that when you're talking, it's really nice. Then I can quickly do the next topic, right? So when you're talking, it's really, really nice. So please talk. So that's really appreciated. Those who can contribute like that. Okay, others also. I'm not disappointing you. Please try to talk. Kian, kata karan, baya wenna epa. You are from everywhere in the island. You are joining from everywhere in the island due to this pandemic situation, and that is anyway very good because you can interact with the students in other schools. So you know that even I'm doing classes these days from grade 6 onwards up to 13, even for A levels. There are students from different regions. Even some are they are from different countries, right? So it is very good that you can interact with each other. And the one important thing, so this interactivity and the thing. So ICT, may ICT කියන එක පුතේ මේ ඔයාලා this is like a weapon. මේක weapon එකක් වගේ. multi barrel එකකට missile එකකට වැඩිය වටිනවා ඔයාලට තියෙනවා. Because using this weapon you can do much more. You can do, it's unimaginable, right? So actually so it will take some time, but let me show some usages. So I think, so let's go to this one. So this is one example, right? When we learn that today I plan to teach logic gates, but let's forget that it's not so, because before doing that we have to finish the fundamentals now. So I'm not going to do this today. So this is circuit construction kit. This is a game actually, but you can use this game to learn about electronics. You can use these games to learn about electronics. So here, let me show this. You have a bulb, you have a battery, and let's say you have two switches like this. And if you are connecting this wire to the battery and this wire to this switch, and if you are connecting these two switches also, so how you can turn on this bulb? How you can turn on this bulb?
Switching on the both bulbs,
Both switches you have to switch on. Then only you can lighten up the bulb. Yeah, both switches. Because if you here this one switch is off, then no way to go the electric signal. So electrons, those electrons cannot go through because this path is not complete. Here these are the electrons. Electrons are staying in the same place because it cannot go. Normally what happened, electrons are traveling from the high density place to the low density place. ඝනත්වය වැඩි තැන ඉඳන් අඩු තැනට ඉලෙක්ට්‍රෝන ගමන් කරනවා. ඉතින් අපි කියනවා අනිත් පැත්තට ධාරාවක් යනවා කියලා. ඉලෙක්ට්‍රෝන යන අතට විරුද්ධ අතට ධාරාවක්. කන්වෙන්ෂනල් කරන්ට් එකක් යනවා කියලා. දැන් ඉලෙක්ට්‍රෝන එක තැන තියෙන යන්න බෑනේ. අර ටැප් ලයින් එකක් වගේ. මොකද මෙතනින් කැඩිලා යන්න බෑ. If you close this switch, now electrons can go. Here negative එකේ ඉඳන් යනවා. මොකද ඍණ එකේ තමයි ඉලෙක්ට්‍රෝන වැඩි. එතන ඉඳන් ධන එක දක්වා ඉලෙක්ට්‍රෝන යනවා පිළිවෙලට. එහෙම යනකොට අපි කියනවා කරන්ට් එකක් යනවා කියලා අනිත් පැත්තට. ධන එකේ ඉඳන් ඍණ එකට කරන්ට් එක යනවා කියලා කියනවා අපි. එහෙම ඉලෙක්ට්‍රෝන ගමන් කරනකොට. So this is AND logic. අපි logic gate ඉගෙන ගන්නවා. This is called AND logic. Switches තුනක් තිබ්බනම් මොකද වෙන්නේ? කාටද කියන්න පුළුවන්? If you have 3 switches, what will happen? I'm going to connect this switch to and this switch. Now I have 3 switches. Now, how should I lighten up this bulb?
switch on 3 switches.
Yes, all three switches must be closed. Then only it will send the power. This is AND logic. We will learn AND gate. Don't worry. We will learn AND gate. But we can experiment that using this. And not only that. So let me show another thing. Let me show another example. This is not for IT. But if you have IT, that's a weapon. You can learn anything, right? I think you have done this practical in your, maybe in your science lab. I think you have done this practical in your science lab. Let me show this. Okay, this one. Okay. So here in this layer you have water. Here, water. The first layer you have air. What will happen if I turn on this switch? Why this light is bending? Why this is bending? Yes. If I send like this, why it is bending? මේක හැරෙන්නේ ඇයි නැවෙන්නේ ඇයි මෙතනින් මේ උඩ තියෙන වාතය පල්ලෙහා තියෙන ජලය air and water, why this is bending? I think you have done this practical, no? In science lab කරා නේද? කරාද නැද්ද? How many of you have done this practical in science lab? No one. කරේ
Yeah,
නැද්ද?
done, sir.
Yes?
Yes, I have done.
You have not done? Or done? I cannot hear you properly.
Done.
Done. Okay. Why it is happening? Because the refraction factor. Refraction factor කියන්නේ වර්තනාංකය. Refraction factor. So that is difference. ඝනත්වය වැඩි මේ වාතයේ ඝනත්වය අඩුයි, density is low. Here you have high density. Therefore it's slowing down. The light is slowing down. Therefore here, so if you analyze the wave format here, slowing down, therefore you can see small bend in there. And if it is glass, more bending. Right? You can increase that, but what will happen if you increase further? If it is become a metal, it will not, light will not travel. So what is this part? The light color one, what is this part? The light color one is reflection from that surface, right? From this surface, there's a reflection as well as the refraction. This is reflection, පරාවර්තනය. හරි, දැන් මේක වැඩි වෙනකොට පරාවර්තනය වැඩි වෙනවා. මේ වීදුරු වලින් ටිකක් වැඩිපුර පරාවර්තනය වෙනවා. තව යනකොට තව ටිකක් වැඩිපුර පරාවර්තනය වෙනවා. එතකොට මේ පැත්තට යන ප්‍රමාණය මේ පැත්තට යන ප්‍රමාණය, if you sum them up, you can create this one, this wave. Because energy cannot be disposed completely. Energy will be converted to some other energy format. That is the law. Right? Likewise, you can use this to learn many things. You can use this to learn many things. If you don't like science, okay, forget about science, forget about maths, forget about IT. But if you like aesthetic subject, so if you like aesthetic subject like music, you can still use ICT. And if you are bored, if you feel bored and if you want to play with your keyboard, you can do something like this. Okay, if you feel boring, so you can play with your keyboard and play music, right? And you can compose music, you can do something. So ICT can be used for many things, right? Not just for computing, it can be used to learn some other things. Here another example. So you can increase the frequency of this one, so you can decrease the frequency. Now it's very slow and very slow. You can see the wave created, and this is to measure wave in two places, the difference between two waves. You can see this is like oscilloscopes. So I'm not going to teach science, okay? I'm not going to teach science, but anyway, you can learn science, mathematics, music, dancing, aesthetics, any other subjects, even language, language translation, anything you can learn from ICT. So if you go to Google, you can simply do language translation. Okay. So click this and ask something from Google and it will translate for you. I like you in Hindi.
In Hindi, you would say, मैं तुम्हें पसंद करता हूँ.
Okay. I like you in Japanese. I like you in Japanese.
In Japanese, you would say, 私、あなたが好き.
Okay, if you want, you can even learn a language. Right? That is there. So that is additional thing. So if you learn ICT, ICT is really useful because it can be used to learn other technologies, other things. So you have to love this subject because you can do even more than you think. You can start your own business. So do you know this girl in this channel? Village Life channel. Do you know the owner of this Village Life channel? She is the youngest Sri Lankan awarded YouTube Gold Play button. She's the youngest. She's only, I think she's like 11 or 12 years old. She has 1.8 million subscribers. It's closer to 1. That is even more than these media, public media channels. They are having more than, so she's an individual, but she's having more than what she's doing. She's earning, right? She's earning just by cooking. She's also not cooking. Her grandmothers are doing the cooking part. What she's doing, she's explaining the food and the method or the recipe. And by just explaining the recipe, she's earning in millions. Right? See the powerfulness of ICT. She's only 11 years old, still schooling, like you all, even younger than you, but a millionaire. Right? So she has earned her own money while schooling. So think about these things. Think about the opportunities. It's limitless. She's from Sri Lanka. She's the youngest awardee. Got the YouTube Gold Play button for 1 million subscribers. Right? Please learn from them. Okay, let's go back to our lesson quickly. And we were discussing about number systems. Let's back to the lesson. Okay. So then I want you to write this one for Octal now. Okay, Octal number systems. The next one is Octal number system. Please write down the same for Octal number system. What is the base? Octal or base 8? What is base? Hello. Again, sleep mode.
8.
Base is 8. What are the digits? What are the digits? 0 to. Here, remember, in base 2, you have 0 to 1. Before 2, it's over, 0 to 1. Base 10, 0 to 9. Base 8, 0 to. Before 8, you have to end. 0 to 7. Okay. So then I'll give you one thing. 452.32. Four, 3.43. So let's write this in. Okay. So no need to write this lengthier one. Let's write 4. Just 4. It's enough. So can you draw the table, this kind of table, and explain the positional values. You have to do this alone. Complete this quickly. Base 8. And draw this table. I'm going to erase this and delete. I'm going to insert a new one. Okay, just fill this. I have 4, 5, 3.4. 4, 5, 3.4. Okay, now you have to write the positional values. And so positional values means the base values and the positional values, and then multiply them and try to find the value in decimal. What is the decimal value for this? I'll give you like, okay, 2 minutes. Quickly do this within 2 minutes. Okay, tell me what is the base value of this one? This is 8 to the power. Yes, talk now, please. Hello.
0.
8 to the power 0. Yes, correct. So you have to repeat the same thing that you have applied the previous one. This is 8 to the power 1. This is 8 to the power 2. 8 to the power 1, 8 to the power 2. And this is 8 to the power minus 1. Okay, 8 to the power 0 means ones. 8 to the power 1 means
8.
8. 8 to the power 2 means
64.
64. 8 into 8. Correct. You know the mechanism, no? Any number to power 0 is 1. Here also 1. 10 to the power 0 is 1. 2 to the power 0 is also 1. Any number to power 0 is 1. Any number to power 1 is same number. 8 to the power 1 is 8. 10 to the power 1 is 10. 2 to the power 1 is 2. Any number to its power 2 is number into number. 8 into 8, that is 64. And what is this one? 1 divided by 8 to the power 1. 1 divided by 8 to the power 1 is equal to 1 divided by 8 to the power 1 is equal to, yes?
0.5.
1 divided by 8. Sorry, 1 divided by 8. 1 divided by 8 to the power 1 is equal to 1 divided by 8. Means 0.125, no? 1 divided by 8 is 8 එකයි කියන්නේ කීයද? 0.125. 1.25 8ක් තමයි එකක් වෙන්නේ. Understood or not? Understood or not? Unclear? Clear නැද්ද? දැන් 10න් ඒවා එකක් ඇවිල්ලා 10න් එකයි 10න් එකයි කියන්නේ 0.1. මට මෙතන ලියන්න බැරි වෙලානේ මම මේක ගත්තේ කොහොමද? 0.1 වැඩි කිරීම 5 තමයි 0.5. හරි? මෙතන 0.01 වැඩි කිරීම 6 තමයි 0.06. මම ලියලා නැහැ. මෙතනත් එහෙමයි මේ 1 වැඩි කිරීම 0.5. 1 වැඩි කිරීම 0.25. එතකොට මෙතන එන්නේ 8න් 1 කියන්නේ 0.125. හරි. දැන් මට කියන්නකෝ මෙතන එන්නේ කීයද? 64 into 4. කීයද? Then 8 into 5. Here 1 into 3. Here 0.125 into 4. So what are the values? Yes, 64 into 4.
256.
Correct. 8 into 5,
40.
40. 1 into 3 is 3. 0.125 into 4, 0.125 into 4,
0.500.
0.500. You can write 0.5. Then what you have to do, you have to add 256 plus 40 plus 3 plus 0.5. Then the answer is 2, 9, 9.5 in decimal. Understood? Correct? 256 plus 40, 296, 296 plus 3, 299, 299.5 in decimal. How many of you got this answer? How many of you got this answer? No one. Mulatika 299 නාපු කට්ටිය කියන්නේ 299 299. How many of you got 299? I think okay, you need more time to do this and check. Okay, shall I give another one or let's move to the hexadecimal? What do you prefer? තව එකක් කරමුද නැත්නම් hexadecimal වලට වගේ යමුද? I need your feedback. Shall we do another one or shall we go to the hexadecimal? Tell your preference, Baba. කියන්නකෝ අනේ ඔයගොල්ලෝ මට එහෙම තමයි අහන්න වෙන්නේ. ඔයගොල්ලෝ මට
Hexadecimal.
hexadecimal, right? Okay. Then let's go to the hexadecimal, right? So that is the last one that we are going to learn. Okay. In computers, we are using binaries. In computers, we are using binaries, right? But we use decimals. That's why this the main ප්‍රශ්න ඔක්කොම එන්නේ හේතුව තමයි ඒක. Computers are using binaries, but we are using decimals. That is the main issue, right? Computers can understand these kind of things. You switch on or switch off, computer can understand. When you switch on something, the computer can understand. Again, when you switch off something, computer can understand. Similar to what we have discussed in this circuitry building part. Right? On and off, you represent using 1 and 0. That is the computer's mechanism we call machine language. The bulb එකකට තේරෙන්නේ switch එකක් දැම්මම පත්තු වෙන්නයි. When you turn off the switch, it will turn off. Switch එක off කරාම bulb එක නිවෙනවා. Switch එක දැම්මම bulb එක පත් වෙනවා. ඔච්චරනේ bulb එකට තේරෙන්නේ. Switch එක දෙපාරක් දැම්මොත් මොකද වෙන්නේ? If you turn on switch 2 times, bulb will still lighten up. Turn off its switch 2 times, still it will turn off. What will happen if you do something like this? On off, on off, on off, on off. Switch එකක් ළඟට ගිහලා එහෙම කරොත් මොකද වෙන්නේ? The bulb will on off, on off, on off, and on off. So that's why in your computer, can you remember this kind of symbol in your computer? කාට හරි මතකද කියන්නකෝ? මෙහෙම computer මෙහෙම symbol එකක් තියෙනවා computer එකේ මතකද? 0 and 1. 0 and 1. Can you remember this kind of symbol in your computer? දැකලා තියෙනවද මෙහෙම එකක්? Yeah, that is power button. That is shutdown button. It can understand to turn on or off. That is power or shutdown button. Because that is what computer can understand. No? On off. That's all. Everything should be given in this 1 0 1 0 1 0. Everything should be given in 1 0. That is the problem. That is the challenge. Okay, since you have that challenge, that's why we learn these number systems. That's why we learn these number systems. Okay, let's go to the hexadecimal one. In hexadecimal one, we call that is base 16. Base is 16. And what are the digits? Digits are from 0 to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Why you have A, B, C, D, E, F? Why you have A, B, C, D, E, F? Yes? You can't write 10 here, because if you write 10 here, what will happen? You are reusing this 0 and this 1. You are reusing. So symbols should be unique. You can't reuse existing symbols. Therefore, instead of writing 10, you write A. Can you write G, H, I, J, K, L, M, N, O, P in hexa? Can you write G here, H? Can you write? You can't. Why? You are going to, yes, you are going to end this from 15. Because base 16, you start from 0 and go up to 15. 15 is F. 15 is F. 0 to 15. 0 to 15. 15 is F. You are going to finish with 15. That is F. Understood? So here, again, I'm revising base 2. It's from 0 to 1. You finish before 2. Decimal, start from 0. It will go up to 9. You will finish before 10. 9 is the last. Base 8. 7 is the last. Base 16. 15 is the last. Understood? And clear? තේරුම් නැද්ද? තේරුම් නැත්නම් අපි ආයෙ කරමු. හරි අපි අහමුකෝ කීප දෙනෙක්ගෙන්. Rashmi, did you understand?
No, sir.
Okay. Timasha? Timasha?
Understood, sir.
Okay. Devmini? Devmini? Okay. Anuja?
Okay, sir.
Okay. So if you understood, so then so anyone else? කාට හරි තේරුම් නැති කාට හරි Vanshika, did you understand? Vanshika?
Yes, sir.
Okay. Then let's move and write this. Let's write an example. I'm going to write A 93.8. A 93.8 in hexadecimal. Because you can write letters and numbers both. A 93.8 in hexadecimal. You can write letters and numbers both. A 93.8. Okay, so then shall I write the table quickly? Can you do this with me? This is A, then you have 9, then 3.8. A 93.8. So what are the positional values? Yes, what are the positional values? Hello. මෙතනට එන්න ඕන මොකක්ද? Am I in wrong class? What is to be written here? Yes? Come on, you have to tell me the answer.
16.
16 to the power 0. 16 to the power 0. Here, 16 to the power 1. Here you have 16 to the power 2. Here, 16 to the power -1. So the number is A93.8. 16 to the power -1. And what are the values? What is 16 to the power 0? What is the value of that?
1.
1, correct. 16 to the power 1, what is the value?
16.
16. 16 to the power 2, what is the value? Sixteen to the power 2, what is the value? Yes. 16 to the power 2.
32.
16 into 16 means 16 into 16.
256.
256. Okay, correct. 16 into 16 is 256. Then you have to multiply these things. And here 16 to the power minus 1 means 1 divided by 16. 1 divided by 16. Here 1 divided by 16 means 0.0625. 1 divided by 16 is 0.0625. You have to multiply 0.0625 by 8. And now can you tell me the answers? 256 into A, then 16 into 9, here 1 into 3, that is 3. And what are the values? Can you tell me the values? Yes, quickly. Two, 5, 6 into A. A is what? A means after 9 you have A. That means 10. 256 into 10 is
2560.
okay. So what is 16 into 9?
144.
Sorry.
144.
144.
Then okay. So 0.065 into 8. Yes.
0.5.
0.5. Correct. Very good. So then what you have to do is you have to add these numbers. 2560, 2560 plus 144 plus 3 plus 0.5. And then the answer will be here 3 plus 4, 7, 7 will be there. Then you have 4 plus 6, 10, and 1 remaining, that is 6. And this is 2.5 in decimal. This is how you find the answer. This is how you find the conversion. 144, you have to add that to 2560 is 3604 and 3 plus 0.5. Okay, write down this, and with that I'm going to finish for today.
Excuse me, sir.
Yes.
Sir, 10 එක කෙලින්ම 8 ගුණ කරාම 0.5 නේ දෙන්නේ.
Oh, එහෙම කරත් කමන්නේ. 10න් එක කෙලින්ම 8න් ගුණ කරන්න. 8 බෙදීම 10න් 8 බෙදීම 16 කියන්නේ 0.5. That is easy.
Sir.
Okay. Okay, please write down this, and from this actually we are going to stop for today. I'll share this note with you in Edmodo. Those who have not created Edmodo, I'll upload this to Edmodo. Those who have not created Edmodo, please create Edmodo account. You can send me a WhatsApp message and create the Edmodo account. Then I'll upload this to the Edmodo. Okay, if you're finished writing, you can leave the class. If you're finished writing, please leave the class. Others, you can still finish the writing and copy the note, and then we'll stop and we'll discuss the remaining part on next day. And remember that I'll upload some questions. I'll upload some questions in Edmodo. Please answer those questions. Okay. Please answer those questions. I'm uploading from the same domain, same questions. මේ වගේම තමයි මම upload කරන්නේ. Please answer those questions by next day. Those who didn't have time, please go to the questions and upload. Answer. Do you have any other questions before we stop? Any question? Okay, then we'll see you all on next week. Please remember to come to the class on time. Don't miss the classes. It's very important. You have only this part as the mathematics. Okay, with that, I'm going to stop for today and we'll see you all in next day. Good night. And again, wish you a very happy new year.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.